So we looked at two things yesterday. One of them being that you can graph lines by finding their intercepts. Most lines have two intercepts. Most lines have an x-intercept and a y-intercept. And you can find them algebraically. First, the x-intercept, remember, is always where the other variable, y, is 0. So we saw yesterday that when you let y equal 0, that term disappears. Because 3 times 0 is 0, and 2x take away 0 is still 2x. So when you let y equal 0, that term disappears. You're just left with 2x plus 12 equals 0, which you can now solve for x by subtracting the 12 from both sides and then dividing both sides by 2. And negative 12 divided by 2 is negative 6. This value of x came from letting y equal 0, so you'll get negative 6 comma 0. That's the x-intercept. That's where the graph crosses the x-axis. Right, so that's that point right there. Do you have chapter 7 booklet? Pardon? No, not today. Grab one over there on the pile. All right, so that is the x-intercept. The y-intercept is where the other variable x equals 0. So you let x equal 0 in the equation, and again that term will just disappear. 2 times 0 is 0. 0 take away 3y stays negative 3y. And then you solve for y. If we add the 3y to both sides, and you don't have to do this, I mean you could move the 12 over, and then it would be negative on the other side. The 3y would be negative, and you would divide both sides by negative 3, but by doing it this way, you don't have any negatives anymore. It'll work either way. But 12 divided by 3 is 4. That's what y equals. This is what you got when you let x equal 0. So 0 comma 4 is the y-intercept. It's where the graph crosses the y-axis. And you can put that point on the graph and then draw a line going through those 2 points. Right, so that line looks something like that, and our lines always have arrows on the ends because they extend forever following those same directions. Right? So for question 2, we're doing the same thing. We want to graph it by finding the intercepts. The x-intercept is always where the other variable y is 0. Because to get to the x-intercept, that's a point on the x-axis, you don't go up or down to get there. You just go left or right. And because you don't go up or down, y is 0. So we've seen that if you let y equal 0, that term just disappears. So we're not even going to write it. Right? You're going to have the 3x, and then you're going to have the minus 9. If you let y equal 0, that y term disappears. And then it's a matter of solving for x. We'll add the 9 to both sides, and then divide both sides by 3, and x equals 3. This is what you got when y was 0. That gives you the x-intercept, where the graph crosses the x-axis. It's 3 comma 0. And then the y-intercept is where x equals 0. So the x term disappears. You'll just have the negative y and the minus 9 equals 0. Which, if you add y to both sides, it'll become positive y on the right side. The 9 stays negative. This is what you got when x was 0. Y worked out to be negative 9. So that's the point 0 comma negative 9. That is the y-intercept. right there. And now we will draw our line going through those 2 points, and we'll put an arrow on both ends because, again, the line extends in those directions forever. So before in section 7.1, we learned all about graphing a line by finding the slope and y-intercept by putting the equation in the form y equals mx plus b. This gives us a different way that we can graph lines, finding the two intercepts. Okay? So number 3, again, we want to graph these by finding our intercepts. Princess, what do we have to do to find the x-intercept? What do we have to do to find the x-intercept? Can you help her, Cheney? What do you have to do to find the x-intercept? That's right. You let the other variable y equals 0. And when y equals 0, the y term disappears. You'll have the 4x and you'll have the minus 12. But the y term just disappears because 6 times 0 is 0. And then we will add 12 to both sides and divide both sides by 4. And you'll get x equals 3. So Declan, what's the coordinate of the x-intercept? That's right. We let y equals 0. X worked out to be 3. So it's the point 3, 0. That's the x-intercept, where the graph crosses the x-axis. Emil, how do we find the y-intercept? That's right. Let the other variable, x equals 0. So the x term just disappears. You're left with negative 6y minus 12 equals 0. So, I mean, you can add the 12 to both sides. And then to get y by itself, you divide by negative 6. And y will equal negative 2. 12 divided by negative 6 is negative 2. So, Brooklyn, what are the coordinates of the y-intercept? Right, because we let x equal 0. Y equals negative 2. This is the y-intercept. This is where the graph crosses the y-axis. 0, negative 2. So now we can draw a line going through those 2 points. And there's that line. Okay? Number 4. How do we find the x-intercept, Keen? You let y equals 0. Yes. So again, the y term disappears, so you're left with 5x, and then you have a plus 10. Need to solve for x. We'll subtract 10 from both sides. That gives us negative 10 on the right. And then divide by 5, and we'll get x equal negative 2. Negative 10 divided by positive 5 is negative 2. So, Chloe, what are the coordinates of the x-intercept? The coordinates. Coordinates has brackets with an x, comma, y value. Negative 2 what, sorry? Is that right, Allie? Yeah. We let y equal 0. We got x equals negative 2. So negative 2, 0 is the x-intercept, where the graph crosses the x-axis. So now we need to find the y-intercept. How do we find the y-intercept, Brock? That's right. We let the other variable x equals 0. So again, the x term disappears. You're left with the 2y and the plus 10. So now we need to get y by itself. We would start by subtracting 10 from both sides and then dividing both sides by 2. And we get y equal negative 5. So Kenzie, what are the coordinates of the y-intercept? 0, negative 5. And so that is the y-intercept, where the graph crosses the y-axis. We can now draw a line going through these 2 points with arrows on both ends because the line continues forever in those directions. The first line has a positive slope because we're rising as we go left to right. The second line has a negative slope because we're falling as we go left to right. Right, so that's one of the things we looked at yesterday. Now these equations are a little bit different because they have only one variable. It says sketch each one, identify the intercepts, and state the domain and range. So equation A is a line y minus 3 equals 0. Again, this one has only y, not x. And we have done equations like this before. If you add 3 to both sides, you'll get y equals positive 3. So remember what that means is that the x values can change, but y is always positive 3. When x is 0, y is 3. When x is 2, y is still 3. When x is 5, doesn't matter, y is 3. When x is negative 1 or negative 3 or negative 4, y is still 3. So this line will be a horizontal line. That's the line y equals 3. X can change, but y is always 3. The domain of this graph, remember domain is asking does it go left and right and how far? The domain goes from negative infinity to positive infinity. But the range has only one value, and that is positive 3. And notice I'm using square brackets here. If you use round brackets, you're saying the 3 isn't included. But it is. In fact, that's the only value of y that's part of that range. So there's the first one. The second one has only x. The second one is x plus 4.5 equals 0. So if you get x by itself by subtracting 4.5 from both sides, you get x equals negative 4.5, which means that the y values can change, but x is always negative 4.5. So when y is 0, x is negative 4.5. When y is 2, it doesn't matter. X is still negative 4.5. When y is negative 3, again, that's fine, but x doesn't change. It's always negative 4.5. This is a vertical line. And we always put arrows on the ends of our lines because they extend forever in both directions, following the same pattern. Our domain here has only one value, and that is x equals negative 4.5. This graph doesn't go left and right at all. It has only one x value, negative 4.5. But our range goes up and down forever. Our range goes from negative to positive infinity. And remember, the rounded brackets are used here because the n values are not included. The last one is just y equals 0. So this means that x can change, but y is always 0. When x is 1, y is 0. When x is 4, y is 0. When x is negative 2, y is 0. This is actually the equation of the x-axis. The x-axis is the line y equals 0. Whereas the vertical one was x equals negative 4.5. So if we're going to state the domain and range for equation C, which was y equals 0, this graph goes to the left and right forever, so the domain will go from negative to positive infinity. But there's only one value that belongs to the range, and that is 0. And again, if you're going to use this notation, we have to use square brackets, not rounded brackets. And if you wanted to, you could write 0, excuse me, comma 0. That's fine too. Or you can just write the first 0, but again, you have to use the square brackets to make sure that those are included. So for, excuse me, equation A, x minus 3 equals 0. To graph it, you'll get the x by itself by adding 3 to both sides. This tells us that y can change, but x is always 3. When y is 0, x is 3. When y is 2, x is 3. When y is 5, x is still 3. When y is negative 2, x is 3. So there's that line. And our domain has only one value, 3. The graph goes up and down forever, though, so the range goes from negative to positive infinity. Equation B just says x is 0. This is actually the equation of the y-axis. When y is 2, x is still 0. When y is 5, doesn't matter, x is 0. When y is negative 3, x is 0. Again, this is the equation of the y-axis. Right? This is the line x equals 0, whereas the first one was the line x equals 3. So the domain of the first one, or excuse me, of x equals 0, is just simply that x is always 0. This graph doesn't go left or right at all. It has only one value on the x-axis. But because you're going up and down forever, the range goes from negative to positive infinity. Brock, what would we do for equation C? If I want to graph that, what would we do? Sure. So that would give you y equals negative 2. Now what? How does that help us graph it? This tells us that no matter what x is, and x can change, y is always negative 2. When x is 0, y is negative 2. When x is negative 3, y is still negative 2. When x is positive 5, y is still negative 2. This is a horizontal line. With arrows on both ends because we go in the same direction forever. In this case, our domain goes from negative infinity to positive infinity. One option we could do is set notation, all values of x such that x is an element of real numbers. That's another way of saying negative infinity to positive infinity, all real numbers. But our range has only one value. That is the value negative 2. Okay? The other thing we looked at yesterday was general form of an equation. So remember, general form has three characteristics. Everything on one side equal to 0 to the other. No fractions or decimal. The number in front of x is positive. For question number 1, we have no fractions or decimals. So we just need to put everything on one side equal to 0 on the other and make sure that the x term is positive. So what do, Keaton? You need to stay with us. We will subtract 2 from both sides because the x term is already positive. And then also remember the order was that we have our x term first, our y term second, our constant last. There's the equation in general form. Now for the next one, we've got a denominator. We have a fraction of a half, meaning a denominator of 2. We need to get rid of that denominator by multiplying all the terms by the denominator of 2. So that's what this is showing. We're multiplying everything by 2. And the reason this works is because that middle term, when you divide 2 by 2, they cancel. We've gotten rid of the denominator. But we have to multiply the 2 out on the other term. So 2 times 5x is 10x. You're left with minus 1 times y, or minus y equals 3 times 2, which is 6. Are we done, Olivia? Why not? Got to make it equal to 0. Because the x term is positive, we're going to leave it on the left side. That means the y will stay on the left side. We'll just bring the 6 over by subtracting it from both sides. And remember the order, x term, then y term, then number equals 0. So now it's done. Liam, what do you think we do for number 3? The least common multiple of 3 and 2 is what? 6. That's the common denominator. So now you're going to multiply everything by 6. So the 6 that's on the left side gets multiplied by 6. All the terms get multiplied by 6. So that's what that shows. And the reason we do this is because 6 divided by 3 is 2. You've gotten rid of that denominator. 6 divided by 2 is 3. We've gotten rid of that denominator. If you multiply out what's left, 6 times 6 is 36, and that equals 2 times 2, which is 4x, minus 1 times 3, which is 3y. Are we done, Ava? What do we need to do? So what would you do to make it equal to 0? Okay, well, why not bring the 4x and the 3y over to the left side? Why not? Well, it would be simplest, but it wouldn't be in general form, because if you did it that way, you'd make the x term negative. We always want the x term to be positive. So that's why you're going to bring the 36 over by subtracting it from both sides, because the x term has to be positive. Now it's done. Okay. Jan, what do we do for number 4? Yeah. The common denominator here, because you got denominators of 4, 2, and 3, will be 12. So we need to multiply everything by 12. And so 12 divided by 4 is 3. 12 divided by 2 is 6. 12 divided by 3 is 4. If you multiply out what's left, you have 3 times 3, which is 9x, plus 1 times 6 equals 2 times 4, which is 8y. We've gotten rid of our denominator, so now we just need to make it equal to 0. Remember, you always want your x term to be positive, which it is. Question, Jan? So what do you do next? Right. And remember that the y term is the second term. The order is x, then y, then number, and you want the x term to be positive. So now it's in general form. So it's the same equation as the original one, it's just in a different form, that's all. Same equation. Okay, so those next 2 pages, page 51 and 52, is what your homework is. Do you have a question about that, Keen? If you did it already, then hand it in and go to the office because you're in trouble. If you did it already, hand it in and go straight to the office. Tell Mr. Rushton that you've been a very bad boy or a very bad girl, and you'll never do it again.